Okay, yeah. So my name is Jessica Kerr. I'm Jessitron online, and I work at Atomist. We do a delivery and development automation platform. And when we were choosing a language to use for this, it was important to us to use one that was accessible to a lot of people, because our thing is your delivery software, like what puts your code into production after you push it to source control, this is production software. So why are we writing it in Bash? Because most CI, you fall down to YAML and Bash, and that's not ideal. So we wanted people to be able to code their delivery in a real programming language. But we needed it to be a programming language that lots of developers are okay with using, but also one that's easy to learn stuff in, because we want people to use our framework and our libraries. So it needed to be something with good IDE integration and help for people who are trying to use a new library, and TypeScript is that. So we picked TypeScript, and so I've been working in it for 2 years. Now, this is all Node. My front end stuff is a little terrifying. I try to do some, but not my thing. So this is all back-end TypeScript that I'm doing. And I'm coming from Scala, Java, Clojure, a little bit of Ruby, but I don't talk about that much because it was a little bit. But I didn't expect to like TypeScript because I had the whole, JavaScript, that's such a terrible language problem. TypeScript is awesome. I mean, JavaScript is so much better than it was back when I formed opinions about it initially. And TypeScript really adds a lot. So it's now my favorite language, not just because it's the one I haven't forgotten as much about, but also because the type system is really flexible. So in this talk, I want to tell you 5 things that I really love about TypeScript, 5 things that make me happy, and 5 things that do not make me happy. And they're not all TypeScript. There's Node and NPM. We don't program in languages, we program in language systems. And this is a very rich language system with a lot of historical context in it. Some for the better, some for the worse, but this is fine. How many people already do JavaScript in some variant? Probably everybody, just about, yeah. How many people do TypeScript? A lot. Okay, so I mean, a lot of this will be intro, but if nothing else, you get to hear my opinions about things. And I do have opinions about things. TypeScript, it's not your usual compiler because it's not going from your source code to something the computer can directly run. It just compiles it to JavaScript. So it's really, I think of the TypeScript compiler as a function from JavaScript plus optional types to JavaScript and compile errors. The fun part is, and some type definitions optionally.
I looked down. Does that say JS Terrors?
It does now. It's supposed to be an A+.
Just as long as we're interrupting you, do you want questions along the way?
Oh yeah. Please interrupt me.
Are you okay with us taking photos?
Yeah.
Okay.
And it's also being recorded, but this talk is a super polished and timed and quick version of this talk is already up on InfoQ. So y'all are getting the interactive, we're not entirely sure what comes next version, which is more fun. Yeah. So I'm talking about TypeScript on Node, and we'll talk about 5 things that I like and 5 things that I don't. And we'll start from the beginning. So here I have a TypeScript file open in VS Code. VS Code does not suck. And it's free, and it's in TypeScript, and it's pretty good. And getting better. I heart Microsoft these days. Right, so we have VS Code, and what I have is I've got an NPM project started already. So I've got a package JSON, but that's about it. And then I have one JavaScript file. So let's write some JavaScript to start with. And I will make one sad function, and it will do one sad log statement. Status is, and we'll put the status in there. Okay, and then we'll call it. Okay, so we'll do those two things. And to run that in Node, we would just say node status.js, and then it would fail miserably because I used a constant that doesn't exist. There we go. And now it's happy. Can you all see that? Probably. It says status is running. Very exciting. So now we're going to do a big conversion and make this into TypeScript. Ta-da! I moved the .js file to .ts, and poof, it's TypeScript. We can run the TypeScript compiler on it, and it has conveniently rewritten our JavaScript file to have a new line in the same, different place, whatever. No, Command P. Let's open the TypeScript file. There. So poof, our JavaScript is TypeScript, except it's angry about something. Duplicate function. What on earth are you talking about, duplicate function implementation? I don't know. Probably something to do with me making it in JavaScript and then in TypeScript. When in doubt, restart VS Code. There we go. Now it's happy. Okay. So that's the cheaty way to do it. You can just say TSC, give it some .ts, and it's going to spit out some .js for you. But that's not usually how we do it, because unlike the Java compiler, you might have 3 or 4 compile options that you pass it, and this is my background from the JVM. The TypeScript compiler has rather more options. So you start with typically, by the way, you get TSC from npm install-g TypeScript. And then from there I can run tsc init, and it creates this tsc config.json with some compiler options in it. So the TypeScript compiler has some options, and some more options, and some more options. And these are not all of them. Okay, they didn't put all of them in here. But you can see why you want an actual file. And conveniently, they made it JSON plus comments. Thank God. So you can at least have some explanation of why you picked these things. And it's a lot. But the first thing I do whenever I have a tsconfig.json is fix it. Ta-da! So one of the beauties, probably my number one favorite thing about the TypeScript compiler is that it's gradual typing. Types not, and you don't have to have gradual typing. It's like you get all these choices about how strict you want it to be, and how much of a hard time you want it to give you, and how safe you want to be. So you can start with just rename your .js, .ts. Heck, you don't even have to do that. You can run the TypeScript compiler on your JavaScript. It will infer types and give you type errors for the things that it can already identify you're definitely doing wrong, which is useful. But if you want to do .ts files, you can go directly from JavaScript as long as you set strict to false. But strict is not just one option. Actually, all of these, and I think there's some more that are not in here, are like different things it can be strict about. So you can be granular with how strict you want it to be. So to start with, for instance, okay, I've got strict false. It thinks my TypeScript is just fine. I can decide, okay, what don't I like about this code? Oh, I was going to show you. The JavaScript is identical. So the next thing that we'll want to change is to turn on declaration. And that tells it to output type defs. So TypeScript has this funny thing, move over here, that it kind of operates in 2 spaces. The .ts file produces two output files once you set declarations to true. And one of them is the JavaScript. So runtime land, everything, all the code in your TypeScript file that is doing stuff at runtime gets translated into JavaScript. But there's a lot of code eventually in your TypeScript file that has nothing to do with runtime. You'll import whole things and only use them for the types. And that stuff disappears. It's totally wiped out of runtime land in the JavaScript and only goes in the .d.ts. If what you're doing is just writing a program and it's never going to be a library, you don't have to output the .d.ts, although it's often useful, and I'm going to use it now to show you what TypeScript is learning about the JavaScript. So if I open status.d.ts, dun, 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 which is not found because I'm not running the compiler in the background. Please compile my stuff. Thanks. Now give me my status.d.ts. Dun, 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 dun. Okay, so now TypeScript is telling me everything it knows about my code in typeland. And it says that the function print status, the argument can be anything, and it returns void. Okay, the any type is important there. The colon things, that's like those type annotations that are optional. Any is the default, and it means JavaScript. You can do whatever you want with that, and it'll let you pass anything into there, and it'll let you do anything with it, and it doesn't care. So it's not helping you very much with type safety. Okay, so the first thing that I want now that I'm like moving on this TypeScript conversion is I want the status variable to have a type. But before I give it a type, I want to make the compiler yell at me so that not just this parameter, but all parameters will have types going forward in my code now that it's going to be all spiffy and typed. Make the compiler yell at me. I do that in here. I go down to strict. I turn on the no implicit any. So I'm making it strict about this one thing. And now it tells me parameter status has an any type. So you're bad. Well, I can fix it. It says I have implicitly any type. Show me my problems. Yep. I can fix that one easily. Ta-da! So now it explicitly has an any type, and the TypeScript compiler is perfectly happy, which is not really what I wanted. I wanted to be more specific. So how do I make it yell at me to be more specific? Well, here's another fun thing about the TypeScript compiler. Not only can you gradually tighten the noose in the compiler, but some of the errors you don't even do at compile time, you do at lint time. So tslint, which they're folding this into ESLint, and that'll be ready at some point. But in the meantime, tslint is just like ESLint. It's going to lint your code, except that it uses the compiler. So it uses the TypeScript compiler as a library in order to get more information about your code in order to complain more. And I can turn that on. Let's see, give me the terminal, whatever, how about this terminal? tslint --init, and that's going to give me a tslint.json, which if I click on that, will it open it here? Whatever. tslint.json, and that has this brilliance in it, and it tells you that it's extending the recommended rules. Well, the recommended rules are like coded in tslint. One day I decided I was going to find out what they were, and I had to dig around in the code of tslint to find out what they were, because it's not going to just tell you. That would be too easy. You can't just like click on that and find out what those are. You find out what they are as you go along, and it yells at you, and you get mad at it. So let's see what those rules are now. If I run tslint, the do things right flag for tslint are -project dot, and this points to the directory containing tsconfig, because it has to know your tsconfig in order to use the TypeScript compiler in its rules. And then you want format verbose. Okay, nope, not verbose. Verbose. All right, what do we have here? We have two errors. One is no console. Console.log is not allowed. It doesn't know that the entire point of this sad little program is that one console.log. And the other one, files should end with a new line. So one thing I like about TSLint, when it works, is that if you run it with -- fix, oh right, do things right and fix, it will take care of, now I got one error, it took care of the new line at the end of the file. It could figure that much out and actually make the fix for me, which is nice. Watch out, there are some rules that will change the semantics of your program, especially around conditionals, it doesn't like you to, it likes to pass just a function name to map instead of like argument to function argument, and it changes that, and then your function gets an I because JavaScript, and watch out for the autofix with lint. Some rules are wrong, turn those rules off. But the new line thing, it could do that. That was okay. Now console.log, all right, so before I do anything else, I've got to fix this linting error now that I've turned it on. Yeah?
I just missed it, so it fixed the new line error.
Yes.
Did it actually tell you that it did that somewhere?
Well, it just shut up.
Yeah, that's
Yeah, so here I had the new line error, and then I ran it again, and it didn't give me that error. As far as I know, it does not report what it changed, but get status is good for that. I tried to do linting in separate commits. When I forget, I regret it. But we have part of Atomist's thing is when you push your code, it can just automatically fix stuff for you and then push to the branch. So we have tslint -- fix run as an autofix, so I don't even usually bother running it locally. I just push to GitHub and let the robot do it. Yeah, and then at least it gets in a separate commit, which is nice. Okay, so we have to do something about console.log. The quick fix that VS Code offers is to say tslint, disable next line, no console. That does indeed make it shut up. Okay, the beauty of this is that you have gradual typing, and then you have gradual like rule tightening, and you can just drop out at any line. You can cast stuff as any and do whatever you want with it in TypeScript. And then for tslint, you can shut this off per line, per file, per rest of the file. You can tell tslint to shut up totally for the whole file or specific rules. This one specifies the rule that it should ignore, so you can still get the other ones. So I love that. That's really flexible. You can do that with a compiler too. You can actually say like TSC, there's whatever, I Google it every time. But you can tell the compiler to shut up about particular lines that it complains about too. Because sometimes I just want to see if something is even feasible and I don't want to fight the compiler. One of the things that drove me nuts about Scala was how much time I spent proving to the compiler that it should just try it. Just let me try this thing. And Scala's like, oh no, you must prove it to me that you know what you're doing. I'm like, I don't know what I want to do yet. So I love that here. And I often just tell the compiler to shut up with a cast or something like that. But I don't want to do this. The console.log is the whole point of my program. So in this case, I want to change the rules and say no console false. That will override the recommended rule. And now the green squigglies go away. By the way, there's a do things right flag in VS Code that I have set that says all tslint errors are warnings so that you can tell them from compile errors. I recommend that. Now if I turn on no any, oh, don't put a comma, it'll freak out about that. Okay, tslint is not forgiving. Aha, now I have the error that I wanted. And this is the error message that I wanted. Type declaration of any loses type safety, get with the program and say what you mean. So now I've tightened my noose enough to make myself do things right. And I can say status of string. And now if I try to pass it 4, it will be angry. If I try to pass it nothing, it will be angry. And if I pass it carrots, it will be fine. We can run it. Node status.js. Or I could run ts node on status.ts and it'll compile it on the fly in case I forgot to run the compile. Okay, but I didn't actually want it to say status is carrots. That doesn't make sense. All right, so number one favorite thing about TypeScript is definitely the gradual typing. That's the biggie. Number two is my personal favorite. This is not actually an important thing about the language, except in context, but I just love this. Literals are types. Oh, I wanted to show you that now in the type definitions, it's something is different. The status is a string, but the JavaScript output is identical because the types just go away there. But then what I can do is I can say explicitly, no, I want the status to be running. Like the literal string running is a type. And I can go look at the type definitions, and it's, oh, come on, do it. No, we're not at QCon. There it is. And it says, look, status is running. It has to be the literal string running every time. You're like, why would you do this? Well, the reason I would do it, I mean, I guess I'm just looking for an excuse at this point, but because I like this feature, is, if I make a typo, it tells me. The actual reason that it has these types is because JavaScript. Because TypeScript has the challenge as a language of not only supporting all possible JavaScript ever, which is really, really hard. TypeScript is a strict superset of JavaScript, all the JavaScripts. So it has to handle things like, you can totally name your variables type and value and let or const. You can name your variables all these keywords, which makes the parsing way harder. I'm glad I didn't have to write that. But also, it has to handle creating useful types for all the major JavaScript libraries that have existed. I mean, it has to come up with types for jQuery. And here's another example. This is the type declarations for Node, and one of those things is this, okay, I missed it. Somewhere up there, it says child process. This is like how you would fork off a process in Node, and the types for that, it gives you back a thing that you can put event listeners on. But depending on the value of the string in the first argument to this on function, the rest of the arguments are completely different. TypeScript lets you overload function declarations. You still have to have exactly one implementation because that's type information is gone at runtime. So you have to implement a function once. But you can say there are multiple valid ways to call this function, and you can list all of them. But to meaningfully type that second argument, you have to know the literal value of that first string. So I think this is fantastic. I mean, it winds up actually being useful having literal string types in a couple places that I probably shouldn't stick with forever. I should convert it to an enum, but whatever. In the meantime, I enjoy that. But what I really appreciate is how much TypeScript is embedded and serves the context of what real developers need with our real libraries. In particular because functional programming, just the simple base level of functional programming where you pass functions as values, which we do all the time in JavaScript, all the time. Every callback is one, such as these. I hate functional programming in a dynamic language. I hate it in Clojure. I hate it in Ruby. I hate it in every language where I can't declare the types. Okay, in Clojure you can get some gradual typing too, and I do that, but it's only, anyway. I hate not having types for functions because passing functions correctly is really hard. I mean, if you had the string value and you didn't pass a string, you could find out about it pretty quickly in a dynamic language. It would fail pretty quickly. There's only so much you can get wrong. But when you're passing a function, there's a lot you can get wrong. I mean, you can get like semantic what is that actually supposed to do wrong, but all of the things that get passed in, what are going to get passed into that function? You're not calling it. The child process module is going to call it, and what the heck is it going to give it? And what does it need back? So much easier when you've got the type system yelling at you and saying, oh, no, when you said error, no, you're not going to get a code. You're just going to get an error. And you can pass something back, but I'm not going to do anything with it because it's void. So there's really important clues for how to use the methods correctly in these. Okay, so that's my functional programming plus types rant. And my favorite thing about number 2 favorite thing about TypeScript is these string literal types. And that's why also numbers are a type, and true is a type, and false is this is fine. It's all useful for those distinguishing. In the meantime, here, maybe I want to be able to say that the status just running by itself is boring. I could have hard-coded it then. But maybe it's running or stopped. And that actually is useful for finding typos and for telling people what I expect it to be. Number 2 here, or number 3, my number 3 is discriminated, or these little union types. This OR operator at the type level, I love that. That becomes even more useful when I give it an alias. So I love type aliases, although I didn't give them a number. Type status is running or stopped. Okay, so now I can see what kind of thing I should pass in there, and that's kind of neat. But I can make this even more useful. What if when it's running, I would have more information like where it's running? And maybe when it's stopped, I have like when it was stopped. So I could say, okay, these are going to be an object literal. The status now is an object because it's got multiple information. And it might be running. And then I could say where, we'll let that be a string. Or it might be stopped. Kind is stopped. And then I might have when. Maybe that's a date. I don't know. Okay, good. So now I can specify more information about the status. And it's angry, so I'll tell it that this is a kind of running, and we're at CIC. Okay, now let's try running that. Either one should work. Status is object, that's not very interesting. But now I can say, okay, the status is status.kind, and since we're running in CIC, I want to say in status.where. But now it has anger. It tells me the property where does not exist on type status. Because type status, let's look at if I highlight status, it'll tell me, oh no, tell me its type. Tell me the type of it. Oh, it's got a name, it's status, whatever. So status has that or of 2 things. This is whatever number we're on, the unions. But this knows that not every status that's passed in, it might be a kind of stopped, and then it wouldn't have a where. Unless if status.kind equals running, curly braces. Give it up with the green, T.S. Lint. Okay. There. Okay, so now I checked what the kind was against a literal value, and now it knows. It knows that status is specifically kind running where string. TypeScript is so smart that it looks at like the semantic meaning of the code to figure out how to narrow the type within these conditional blocks. So if I copy the console.log and we go to print out the other one, and I expect this one to be stopped, so it would have a when. Oh, it might not have a when. It might be running until I stick this in an else condition. And then it's like, oh, okay. Now, if it's running here, then it's definitely stopped down here. That's not very useful TypeScript. Great. So it's super smart about that, and that is definitely, I think, whatever number we're on, that is one of my favorite things about TypeScript, type narrowing. And you can do it even cooler. Oh, for one thing, check this one out. If I don't want to pass the status, it'll be angry with me, unless I make status optional, in which case it will let me call it, but then we're going to get some anger there. Cannot read property kind of undefined. So now I want to make it yell at me. Please yell at me for not checking the null. Oh, there's our type in there. It doesn't appear at all in the JavaScript. Come here. I need tsconfig.json, please. And then we can make it angry about nulls. Please be angry. Are you angry? Oh, yeah, now look, it's angry all over the place. Because it knows that the status might be running and might be stopped, or it could be undefined, and now it's all angry at that, unless I say, if status is undefined, then return. Or I can do that cheaty thing and say, whoops, if not status, return. And now it knows that that this code is unreachable for the undefined case. So this is how the TypeScript can actually give you useful errors in your JavaScript. I mean, it can just compile or do some type checks on JavaScript and still give you useful information, which is fun. Okay, so good. But now let's pretend that this print status is in one module, and this type information is in another, and I want to go all object-oriented about it. See, another reason TypeScript is good for the enterprise is the enterprise is used to Java and C#, and TypeScript is actually not nearly as far from Java as JavaScript has been. I can make this an interface. We'll go interface status, and we'll say, okay, your kind is running or stopped. That should be happy. If I hit save, it'll format it. And then I can say, no. Okay, now TSLint in the default rules says my interface name must start with a capital I. That is all Microsoft. We can turn that off, please. Interface name. No, we're not going with that one. That is not a recommended rule. Or well, whatever. I don't approve. Interface name is just fine, thank you. All right. Okay, now it's happy. Good. And now I can make a class running status, and it can implement status. Implements. And then we can give it a kind, a public kind, which is running. And then it can have a constructor, and it can take that when, public, when, where, string. Okay. And so we give it a public field, but now it's angry about kind because it's like, that's a string, and it has to be running or stopped. And I'm like, can't you see that it's running? It's running right there. But actually, it's being clever. There it goes. So if I tell it it's read-only, then it knows it's going to stay running. Otherwise, it's immutable field, and it had to widen it to string. Okay, so now we have a running status. I need to say down here, new running status, CIC, and that should work. And it probably does. If I do node status.js, yeah, it's working. So one thing that I like about TypeScript is that runtime space and the type space being separate means that, oh, I didn't mean to look at this yet. Yeah, we'll explain this in a minute. It still outputted the JavaScript. It totally changed the JavaScript, even though I have compile errors. Of course, you can turn that off as a compile option because everything is a compile option. But I love that. I don't have to make it compile before I run some test or other. That makes me happy. In the meantime, it doesn't know anymore that running is sufficient to tell it that it definitely has a where. Because you could implement status some other way and have a status of running and not have a where field. But I can say instance of running status. Oh, status, instance of running status. Yeah, and then it's happy. And I'm not going to make that one compile. So then it should work again. Yeah, it's still working. But this time, it compiled. All right, happily, I should say. But maybe I don't like running status. I mean, instance of is always creepy. Right, it's too implementation dependent. It says you know the exact class It doesn't have proper interface segregation principle things going on. So instead, I could abstract this a little. Hopefully I can make it a little smaller. And what I want to be able to say is if status is some kind of running status. If it's a running status, then I want to know it has a where field. And I could then define that. Function is running status, and it gets a status. And this function has the bizarre return type of status is running status. What kind of weird return type is that? Well, it's a kind that wants, whatever. It wants a Boolean, is what it wants. Return status instance of running status. Or I could check that the kind is running. I have a choice there. But look, it got happy. It got happy down here because I just told it that if this function returns true, here is some more information about the type of status. So you can make your own custom type narrowing functions that harness the power of TypeScript smart type narrowing. And this is called a type guard. This particular function, you're going to need that in order to Google it for the syntax every time. Because only after having done this talk 6 times do I not have to Google it. Because you don't do it very often, but when you do it, it's really useful. Now, one more caveat. I don't like that this exports. In order to call this function, I'm still going to get something about the concrete class. And that's actually dangerous in TypeScript for complicated reasons that I might complain about if we have time at the end of this. I would rather say, okay, it's a status and it's going to have a where field. So in addition to ors, you also get ands in typeland. And I can say that this is an intersection of these two types. It has everything the status has, and it has this where field. And that's enough for my console.log to be happy. Yeah, so all that type arithmetic, that's pretty awesome. Next thing that's weird is we peeked at this JavaScript file earlier, and I was like, oh, wait, don't look at this yet. And that's because, I made a class. JavaScript has classes. Why did TypeScript output this var running status equals function that is immediately called, And that's because all JavaScript ever. TypeScript not only accepts all JavaScript ever as input, but you get to choose your output level of JavaScript. And a beauty of TypeScript is that it produces the most readable JavaScript it can. It really aims for readable JavaScript, which makes me happy because JavaScript is like the bytecode of the web for now. And it's better than Java bytecode in this one way, that I can read it, at least what TypeScript outputs. And this is Node. Okay, if you're going to put this on the web, you'd run it through a squisher. But for Node, it doesn't matter. I don't need it to be small. But here's the trick. This target field, if I change that to say, please build ES 2018, ta-da, oh, come on, oh, there it is. Yep, it compiled, and now I have a class. So this gets to, come here. Both my number 5 favorite thing about TypeScript and my number 1 least favorite thing about TypeScript is that it has to deal with the whole history of JavaScript. So JavaScript a long time ago was just what Mozilla made it, or Netscape. And then it got a standard, and then there's the 10 years of darkness between ES3 and ES5, during which Microsoft pretty much had a browser on monopoly on browsers and did what they wanted. So standards didn't have a chance of sticking, and then finally Chrome comes out, and is actually competitive and is actually interested in standards, and then everything got better, and now we get a release every year, and things are gradually getting better. We got that big backlog of things into ES6. But these are not all of the JavaScripts. These are only the standards of JavaScript, right? And every JavaScript runtime implements some of each of them. And so TypeScript has to deal with that. Now in the end, where you run your JavaScript is not a question the compiler is going to answer for you. You know, you don't tell TypeScript, I want to target Chrome at this release. You tell it which standard you're hitting, and then you can have ES6, you can have ES 2018 is somewhere over here. And there's always also ES next. So a benefit of TypeScript is no matter which JavaScript you're outputting, you are always at the latest, because TypeScript is always, as soon as something gets sufficiently stable in ECMAScript, TypeScript implements it, and you can always use it in TypeScript. And that is a plus. So one of the things I like about TypeScript is if you look at nobody writes the JavaScript they run, right? You have some runtime that might be as old as ES3 if you're suffering through old browsers, but you write some earlier version, and then you run it through Babel and a bunch of other JavaScript things that I find really painful. I just run it through TypeScript. And now I have the luxury of running on Node. So if I pick a recent version of Node, I can pick ES 2018 or something, which begs the question, how do you know which of those to pick? Because in tsconfig, the first thing you're confronted with is this target. And it defaults to ES5, but this is also one of the first things I change because I want to go with the most recent one I can so that I get the most readable JavaScript. So how do you know which of those to target? Well, it depends where you're going to run it. If that happens to be Node, then you go to this beautiful website, and I mean that for content, not presentation, of node.green, which tells you that nothing actually implements ES 2015, which I think is ES5 or 6, whatever. It says at the top ES 2015, and then, turns out tail call optimization is really hard. But then over on the right, you have all the versions of Node. 13, I guess, is in process. Currently, I think for some of our customers, we have to leave our libraries compiling down to 8, which makes me sad. But let's see. But if you're running Node, you or your organization has some control. So I'm currently on Node 11. So I'm in here somewhere. And what you do is you scroll down in here a long way. There's a lot of stuff in ES 2015. Here's ES 2016. And this says 100% complete. So pretty much everything is good for 2016. Once you make it say 2017 up here, that's pretty good too. 2018, you need to be on Node 10 for ES 2018 or higher. And that's how you get this. For another example, if I were to make, not the JavaScript, just do not change the JavaScript. If I were to make this function async, TypeScript is fine with async await syntax. But if I look at status, let's make sure it runs. I need to make sure that runs. It does. It runs fine. But if I look at the JavaScript, okay, that's fine. It says async, no big deal. If I knock this back to ES5 or whatever, then this is seriously the most readable JavaScript that Microsoft can figure out, and they're right, because what they do is put a bunch of crap and some helper functions at the top in order that our code looks as much like the TypeScript as it can. So it gets it close by putting all the garbage in separate helper functions. Now it can't help you with your stack trace, but not much can help you with your stack trace and async. So that's just a mess. But it tries. So if you can afford the newer generations of output, go for it. And in fact, now I have another problem. It says an async function or method in ES5 requires the promise constructor. Make sure you have a declaration for the promise constructor, or include ES 2015 in your -- lib option. All right. So here's the thing. In your tsconfig, you're not only declaring what JavaScript you output, but you're declaring what types are available globally. Like what's in the standard library that it can expect to have access to at the runtime, because it needs to check your types. And by changing that to ES5, I just told it I don't have promises in my runtime. So I need to go tell it that promises are going to be available at runtime. Okay, so it said, sometimes it says I can include, so here's my lib option, and I can do things like say, okay, I don't have all of ES 2015, which I think is ES6, whatever, but I do have promises. And this is where you get, because all the different browser runtimes and nodes too, they all implement different subsets of the standard. So this is where you can say, and this subset of the standard. Include the types for that. Now this -- lib, this lib, -- lib if you run on the command line, but the lib option in the tsconfig this is all about types. This does not bring in any actual definitions. That's already in your runtime. It's just for the types. And now we're going to get my favorite compile error. I don't mean that literally. Because if I run TypeScript now, cannot find global type array, cannot find Boolean. What is that about? Yeah, so this confused the snot out of me for months, and I just like kludged stuff to get around it. But now I actually understand. Okay, the default, if you don't have the lib option at all, it's going to pick whatever your target is. But if you put anything in the lib, then it's like you're overriding that, and it forgets everything that it knows. And you have to explicitly say, oh yeah, and everything else that I already told you was in JavaScript in the target. So this is one of those things that I hope by me telling you about it, you will have a better experience with TypeScript because you won't trip over it. More likely, when you trip over it, you'll get even madder at yourself because when you figure it out, she'll be like, oh, she told me about that and I still forgot. This is fine. Okay, so now it should work. It compiles. We can run the thing, node status dot, give it the whole file name, running in CIC. Everything's happy again. Okay. So that's fun. And we did my least favorite thing of targets and my least favorite thing of lib. Oh, and then for added fun, you also have to ask that module question there. In addition, I mean JavaScript. There's nothing wrong with it. It's just got a lot of history. And it aims for backwards compatibility. And that means that history doesn't go away. We are context dependent. So back in the day, this just sounds ridiculous, feels ridiculous to me coming from Java, but there were no such thing as packages, right? And people just declared functions and immediately called them because that was the only way to get any privacy, was to encode things in a function. And then they started figuring out that if they standardized that, maybe they could use other people's immediately called functions. They have a name for that. And module systems emerged. Systems. And you have like AMD, and you have CommonJS, and there's a bunch of other ones. And some of these, AMD is mainly for the web, which actually cares about like dead code elimination and crunching things down, and CommonJS is mainly for Node, which doesn't care about that. It will fill up your directory with its Node modules, and it does not care at all, which is great. We'll see that in a minute. But but this is another thing that is great about TypeScript because it encapsulates that. So I do have to choose which module system I want my JavaScript to output to. But once I do that, and it's easy on Node, you just pick CommonJS. But otherwise, you can pick like some universal something, I forgot the name of it, if you want your code to be usable as a library, both on the web and in Node. And that gets into the question of what is a module in JavaScript, or in NPM really. Because again, we don't program in languages, we program in language systems. And NPM is a dependency manager is an intricate, essential part of that language system. This is totally backwards from Java, which really threw me, that a package is the high-level thing, is what you publish on NPM, and a module is a file, is a module, is a file, is a module, is a file, unless that file is a script. Okay, and our file is a script. So I can show you that. This is it's another thing that confused me. We're in the negative things now. Our status.js, oh god, let me just change this back to 2018. It's going to be better, and we don't need this, so that we can look at the JS. Oh, it got so much shorter. All right, it's got the class, it's got the function, it's got print status. It doesn't wrap any of this in a module. It's just a script that you can run with Node. In TypeScript, every module is a file as soon as it exports something or imports something. It calls that participating in the module system. So we can do that if we just export our function over here, export, print status. Then we become a module, and we get some module-y things at the top, and it exports print status, like that. And our .d.ts starts to look different. Status, because it used to have the class and the function and all those definitions, but because we only exported the function, now it's saying, okay, there's that function. I don't even know what that line means. Whatever. And it exported the interface because that is returned by the function. So the function needed to have access to that type just for its declaration, but it didn't include the class or any of the other things because I didn't export those, which is nice because I explicitly wanted my class implementation to be secret, right? So I would still export is running status. I would want that one exported. Poof, now I have the two. But that way, my class implementation is hidden.
But that wouldn't stop it from, if you had, say, type checking that you needed to do purely internal to that JavaScript file, even though it's not spitting that information out to the d.ts file, it still is capable of enforcing rules.
Yes. Yeah. So that running status class is totally enforced inside my status.ts, and it's using it there, and I'm using it here, but it doesn't exist outside from TypeScript's perspective.
It's inferring this type information, writing it out to this file, and then using that to give you warnings, but it's really...
Oh, that's true. That .d.ts is output that's used downstream. So when you publish a library on NPM, you want to publish the .d.ts and the .javascript. People don't usually include the TypeScript file itself because the compiler by default will try to compile your Node modules, and it's really annoying. But you would include the type declarations and the JavaScript, which segues nicely into imports. Because as soon as I want to use someone else's module, then I need to import it. And that, every module system in JavaScript has its own way of bringing in modules. And then somewhere there's require.js, which does some stuff that I'm not a front-end developer. Unfortunately, TypeScript abstracts a lot of this for me, but it can't abstract all of it. So let's say I want to bring in a module. I want to put my printout in a box. Everything is more fun in a box. Just ask a cat. So I'm going to install the library boxin because this is my favorite library on NPM at the moment because it puts things in boxes. If I go look at NPM, let's go get NPM boxin. It tells me, yeah, it does this. See, it puts things in boxes. It's quite charming. It tells me that I want to do const boxin equals require boxin, and then shows me how to call it like a function. So I could copy that into my TypeScript. I'm just going to put it down here. Normally I would put it at the top, but I want to keep it on the screen. And then I should be able to say boxin and put that in there and be like, oh yeah, and give it padding 1. That'll be good. But it's like, require statement is not part of an import statement. Okay, can you fix it? Convert require to import. Good, it can. So this is nice of it. Imports in TypeScript have like 5 forms. Now, it happens to have chosen the right one here because boxin now has types. When I first gave this talk, boxin did not have types, and I had completely different things to explain with this example. But now, boxin, the library itself, has published its .d.ts files. That was an improvement in a new version, and now everything is easier. But there's multiple ways to import things in TypeScript. So for instance, say that child process module that's part of Node, import star as CP from child process. The usual way that I want, CP is declared, but its value is never, the string literal part is fine. Yeah, I know it's not read, but if I do that, I can say cp.spawn, and so I can, yeah, I know you want some arguments, it's fine. Shh. Okay. So now I'm getting the entire child process module. I've given it a name. This is fine. I can call methods on it. I could also get just the spawn method like this and call that directly. Also fine. This is actually an object deconstruction. You can pull fields out of objects by surrounding the field names with curly braces. But that's different from import boxin from boxin. I can't make this make sense. It's so painful. You have to do either the import stars blah or import boxin from boxin, except sometimes you actually have to say import figlet equals require figlet. Sometimes you have to do that, and other times you just use the JavaScript require, and it depends on the internal implementation of the thing you're importing. And there's really no figuring it out. If the thing has published types, TypeScript can probably prod you until you get the right one. I do one, and then I run it, and I see if I get an error. Because you have to dig in. Boxin, now that it has types, somewhere says export equals boxin. If you see export equals or export default, then you want just the name and not the star. But if you don't see that, you probably want the star. I think default exports are crap, and everything should just export an object with stuff on it because then it gives it a name. But other people in JavaScript and TypeScript do not agree with me, so the world is not as I would prefer it. Whatever. We'll fix that in a minute. Okay. So those are imports. I think this is going to work. I think this is going to put it in a box. Ta-da! I put it in a box. And yeah, that makes me really happy. Oh, here's another use for those string literal types. Because in boxin, I can say padding 1, and I can say border color yellow. But what actually works for border color? To find out, I click into here, and I can see border color is one of these colors that you can put the literal strings in the type system. This one happens to also let you put in a random string, which makes me sad. It's a runtime error, but this is fine. It does list the strings for me in the types, and then that makes me Makes it easier for me to choose the right one. And then it's going to be yellow. It is yellow. I'm happy. Okay, so imports are hard. But a positive of imports. The way this works, let's look at in NPM, and this is both great and terrible. Coming from Java. In Java, you have a class path, and all your imports are living in the class path wherever your jars are living. But in NPM, they're not. They're right in your node modules directory. And why do I have this much stuff in my node modules directory? I asked for TypeScript. I asked for that one. Yeah, that's it. I asked for Boxin. And I may have asked for some types. But if you do npm ls, then it gives you your dependency tree. Yes, there's TypeScript. That one's actually mine. And types node. Okay, yes, I did want to bring in like the useful types that exist in my node runtime. Everything else is boxin. You put a frickin' box around the frickin' text. Why do you need all of this? I go like look at some of this, and I hit one the other day. Maybe it was strip ANSI, and I'm like, what even is this crap? And I go to npm, and I'm like, okay, what is this one? Well, that one's actually here. There was another one that I found somewhere, and it was strip end of file, and npm was like, oh no, that's not a thing. Google, I'm like, strip end of file, npm, and it's like, oh yeah, that's totally a thing. I'm like, npm, why don't you find the thing? Google finds the thing, but this package has been deprecated. Renamed to strip final new line to better represent its functionality. What even is its functionality? Let's go to its GitHub and find out. What do you need with this strip end of file? There's a test file, that's nice. There's one file, and wow, you really need these dependency trees. For this, I mean, okay, personal rant, and I was talking about this on Twitter today with Jay Bloom and Rebecca Werfsbrock, of do we really need to create coupling in our system? Who knows the left pad story? Not everyone knows the left pad story, but I'm not surprised that y'all do, because you're in JavaScript land, but somebody deleted their NPM module and the entire web broke. I always get it confused with left shark, though. It happened around the same time. Yeah, and I mean, now NPM doesn't let you delete modules that are more than an hour old. Good job, way to grow up, NPM, but still, that's ridiculous. I mean, it was like a few lines function, and it wasn't even right. There were edge cases that left pad did not even work for. Why are we creating these complicated dependency structures? Cut and paste works just fine. I'm a big fan of cut and paste for this kind of thing. It just avoids creating. There was another one a few months ago that was a big security vulnerability because somebody took over maintenance of an open source library that everyone used, and they used it to inject Bitcoin mining code into half of the web. And oh my gosh, everybody has to panic and remove this dependency, but you can't remove it because it's a dependency of a dependency of a dependency. Cut and paste. It's just not that bad. Bill.
Since we're on this topic,
Yes.
I want you to see my favorite protest module.
Oh, goody. What is it?
FIVE.
Is it on NPM?
Yes.
Oh, awesome. Does it export 5? I'm going to see That's awesome. No, make that bigger. Make that bigger. With a delay. 5 dot too slow. 5 with a delay. That's awesome.
Other than the fact that it's funny, I gotta think that this is someone going, this has gotten out of hand, and I'm going to prove it. And this is what they did.
Exactly.
If you scroll up, you can see that there are actually several collaborators on this module.
Oh yeah, that's a good question. One dependent, 0 dependencies. That's nice.
Similar one is 13. I have the name wrong. It might just be 13. If you can't find it, never mind.
Oh well.
But it's just a whole bunch of different ways to.
10 packages were found for 13. Isn't 13. Rot 13. Always 13.
Yeah, is dash 13, I think is the one I was thinking of.
Which one?
But yeah, ability is 13. Just the.
Oh, it has a dependency. Does it depend on 5? I want to know if it. Fabulous.
A whole bunch of things. Are you 13 in some way or
So if you get the string like born in so long ago.
put in James K. Polk, it will say true because he's the 13th president.
Okay. Nice. Yes. So yes. So it's ridiculous. This is ridiculous in my opinion. Chalk, that one's actually useful. So I think it's like Chalk and its friends are all about turning the text colorful in my terminal. Okay, that's actually useful and not trivial because you need to like work with different terminals and stuff. That one I approve of. This is fine. But I wanted to show you what happens when a library doesn't have types. So let's bring in Figlet. And this is another wonderful package that I find on NPM by searching for ASCII art because I love this stuff. And Figlet, like, come here. It does cool stuff like, it turns your text into ASCII art. Now Figlet, if I recall correctly, does not, last I checked, doesn't have types. So how would I import Figlet? I don't know, let's try one. Probably this. Okay, and now it's angry. It's declared, but its value is never read. No, we don't care about that. Figlet, there, it's read, okay. Yeah, so there it is. Implicitly has an any type. So we turned on that no implicit any. This is the BS from no implicit any. In general, I totally want my parameters to not have implicit any, but this is somebody else's flippin' module, and I just want to use it, okay? I don't care that it doesn't have types, just let it be any. And can I say ;any? No. Well, first it wants me to try npm install @type/figlet. There's this @types user on npm. A lot of people have contributed .d.ts files for libraries that other people have maintained or don't maintain, as the case may be. So that's a place, and I can try npm install types figlet, but it's probably not found. And for my purposes, I don't want to find it anyway, so I'm not going to try. TypeScript gets the ambient type declarations from a couple places. One is those libs, that lib compiler option. It can find stuff in there, but also in your dependencies, especially in these @types places. Ideally, it gets them in the libraries themselves in the .d.ts that are right next to the .javascript. That's the best place. It'll get them directly out of TypeScript files. It's happy for that too, especially the ones in your project. But otherwise, if you want to get this one to shut up and let you use JavaScript modules without turning off no implicit any, there's a secret thing to do. I'm going to make a file called types.ts, and in there I can say declare a module figlet, semicolon. And it's going to find this and decide that's an ambient type, and that counts as an explicit any. That's your explicit any for figlet, is you have to go to some other file, usually called types.ts. I'm not sure if it works with other file names. It's a little iffy sometimes. And you put that declare module figlet. If you wanted to shut up about everything, the secret do things right button is declare module star. And now you can just use JavaScript modules. Now, whether this is going to work or not is yet another question, because I don't know whether I've imported it correctly. Should I have done that or this? Or sometimes you even, depending on how that was exported, you might even have to do the require thing. In this case, this one's a little weird. Figlet does have a function that you can just pass a string to. Figlet. And then I'll just not do that. And the types are not helping me here. But if I run it, do the run thingy. There it is. Unhandled promise rejection warning. That's very bad. Those are very bad. That means something threw an exception somewhere that was lost. And Figlet is not a function. Oh, okay, well, I guess I better import it the other way. Like, seriously, that's the algorithm. Try it as a function, not a function. Let's try the other thing. Okay, well, I got something different. It turns out that if I go look at Figlet, and this is some bonus material. Oh, I have Figlet. It's right here, Jess. It's going to show me how to use it. Oh, it's one of those callback thingies. So Figlet is asynchronous. And my function is asynchronous too, because I gratuitously stuck async in front of it in order to demonstrate something. So I ought to be able to call Figlet asynchronously. But for that, I need to switch it from callback form to promise form. Now, here's the cool thing about TypeScript. Now, I think this is Node in general, this part of it, but TypeScript makes it even cooler. I can say promisify Figlet and import promisify from util. That's just a node built in. And I think if I await it, it won't be. Yeah, so now I can await it because now it's returning a promise instead of requiring a callback. And trust me, this worked. Status is running in CIC in some sort of weird Figlet-y font, which changes a lot if I change my... Okay, anyway, it says that, trust me, in Figlet font. I haven't loaded any other fonts, so this is fine. But that promisify function is really cool. Now, Figlet is fine because its callback is the standard type, function from error to data, blah, 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 blah. But there's a lot of callback-y functions that don't do the callback just according to the standard. The fun thing about promisify is that in their type declarations, I think it's in their type declaration. Well, there's a runtime component too, but you can see it in the type declarations. Libraries can provide implementations for promisify that override the default implementation. So promisify like magically works for stuff that don't even conform to this, which is really neat and surprising and confused the snot out of me the first 10 times I saw it until I actually took the time to look it up. Which in general, when you're moving to any new language system, happens a lot. And eventually you've hit things 10 times and you've actually looked them up and then you start actually knowing what you're doing. That's my experience.
That's the only thing I would add, by the way, to your patented try all the different ways of importing until one works.
Yeah.
Step 0 in that is usually, how do I import TypeScript search? Someone else has already found the answer. And you can usually just do what they did instead.
And it probably still works. Probably. Yeah, but TypeScript is changing and getting better all the time, but it's pretty backwards compatible by now. Okay, so we promiseified the Figlet, and we did that, and we did that, and let's see what else is on the iPad. Right. Okay, so we made our file into a module. We participated in the module system. We imported some NPM packages. And the other thing about NPM packages that like really throws me in Java is how it finds them, because it's so different. And TypeScript like duplicates the Node implementation of this. But what time is it? This is not a clock. It's 8:35. Okay, I don't want to go into that. Suffice it to say, if you export concrete classes, TypeScript has private and protected fields. In general, this part's important. In general, TypeScript is all duck typing. If your class exports the same fields as another class, it might as well be the same, and TypeScript will count it as the same, unless unless the class it's looking for has any private or protected fields. Because JavaScript is not going to enforce that for it at runtime. So TypeScript tries really hard. And because all of the, you've got your project, so what was my project? I don't know, TypeScript for Enterprise. And it has a node modules directory. And inside node modules, it can have, maybe Boxin, that depends on Chalk. But what if it depends on Chalk too? If those are compatible versions of Chalk, then Boxin won't get its own. It'll just use the top level one to minimize. Because, NPM does make some effort not to use your entire disk for node modules. Unlike in Java you would only ever have one version of Chalk, but in Node, you can totally have two. If I said I wanted Chalk 2.0 and Box wanted Chalk 3.0, and the semver ranges don't overlap, it'll very happily give us both. But if I want to pass a Chalk into a Boxin, that doesn't actually happen, but pretend if I were passing some class from Chalk into Boxin, and I passed a class from my Chalk into Boxin, which was not the same as its Chalk, even if they actually were compatible and had the same contents, TypeScript would yell because it would be like, private fields here are not accessible to a class up here. It determines whether the class is the same by its location on the file system, which is occasionally painful for this reason, but way the hell more often if you're trying to use npm link to do local development on a library that calls another library that's on your local file system, and so it has its own copy of the private dependencies, and don't expose classes, don't expose class implementations. I mean, that's good OO design anyway. You should only expose interfaces. And if you do that, you will be safe from this particular hell, which is TypeScript looking at the file system location for classes. Okay, that's my last thing that I did not like. Okay, in conclusion, TypeScript is totally awesome and you should use it. The gradual typing is the best. I mean, it's strictly better than JavaScript, okay? It's a complete superset of JavaScript, except better. Because it's all optional. You can turn it off, not strict, and only use exactly as much as you want. Literal types are fun. Union types are fantastic. And then you get to your choice of JavaScript. So it can replace a chunk of your build pipeline instead of adding to it. Yep. And there were 5 things that I hate about TypeScript, but hopefully they'll not trip you up. And once you get to know them, you know how to get around them, and it's not so bad. I really do like this as a language, as an object-oriented / functional language in general. It is a very rich ecosystem, and a lot of people know it. And you get auto-completion. We didn't see that, but yeah, I should do something that shows that. But once you have types, you get auto-completion in VS Code, and it's wonderful. But if you are coming from Java or C# like me, which y'all are lucky, you already know JavaScript, you have a lot of background here, just be prepared for some pain. The tooling is better in Java, I'll give it that. IntelliJ does good refactoring in TypeScript, but other things it totally screws up. Can't trust it. But VS Code is pretty great. Overall, I have to say, yay Microsoft, great job. Questions, discussion. More funny NPM modules.
Do you start off in, one of the things that we've started doing on projects is we always start in script, like turn on script at the very, very beginning.
Oh, when you're starting from scratch?
Right.
Yeah, why not?
We found it's way easier to just start there than try to get there.
Mm-hmm.
I'm curious to know if that's the same thing that you do, or if you have thoughts on that practice.
In real life, we have some strict options on at Atomism and some off, and we don't have strict null checking on. I often wish we did, but yes, if you're starting from scratch, I mean, why wouldn't you start with strict mode on? Even if you want to override it in a couple places, you can just turn the compiler off for that line. So yeah, I do think you're right. In real life, it kind of depends on your style. I think at Atomist, we have Java developers who are not used to doing null checks and don't want to, frankly. And when the CEO doesn't want to do null checks, well, you don't have to do null checks. But yeah, you're right. You're right. I mean, why wouldn't you start with strict mode on?
I can say there's fewer things more humble than turning on strict null checking and thinking your code's airtight, and then just so many errors, so many just bugs waiting for you to run into.
Yeah, or potential bugs. And usually it's just that that was always optional and you needed to declare it as such, or it was never optional and you need to not declare it. Yeah. Yep, I agree with you.
Have you found given the fact that TypeScript is only about dev time, it's only about compile time, one of the things that I've often wished for, and I'm beginning to see tools pop up, is, I've done all this work to declare all of this information about the data structures in my application, but now I'm fetching something from some RESTful API server, and I've got this big wad of JSON that gets turned into a JavaScript object, and I've said that it conforms to some structure, but I've got no runtime assurance of that. Do you like any tools that are out there that say, enforce these types at runtime against the structure that I've just created or fetched, please?
In Clojure, yes. I don't know the JavaScript ones, really. I haven't used them. Who does? Does anyone have an example of that?
Yeah, this is a problem I run into too, but I really didn't find solutions for it. To my understanding, the TypeScript just helps you at development time, but at runtime, just everything is up in the air, right? Because like ultimately it's just JavaScript, and then yeah, so I think the type guard thing, like if you want to write really elaborate type guards and you check it, you basically create a type guard functions, right? And then whatever data you get from RESTful APIs, and you run those data against your type guard functions. That's a way that you can ensure that. But then that just means you're adding to, even aside from like defining all your types, now you're writing one type guard function for each of them.
Exactly.
And
I'm trying to eliminate the duplicate work. And the funny is, I
Yeah.
see all sorts of tools that go the other direction. Like, I've come up with this beautiful
Oh.
GraphQL schema, and it will generate TypeScript types for me. I like starting in TypeScript, and I would like to have something that can use the type information
Right. To generate a type guard, really.
generate all of what we're talking about. And there are some tools that are headed that way, but I haven't found anything that like the community has said, yes, this is the way we want to do this.
I think part of the problem with that is there's a lot of different backends. If you had a Node backend, well, you could just use the same type definitions on both sides, so everything's good. If you have a .NET backend, well, Microsoft, there's some tools, I don't know .NET, but I've seen some tools that work. If you have a Java backend, good luck. It depends what your backend is. And there probably are Java tools that I just haven't seen them. So.
Yeah, it's probably the same thing as JavaScript, which is there's a lot of incomplete ones that someone put 2 weekends into.
Someone wrote just enough for their stuff.
Yes.
And they're done.
Yeah. That's what I do is I write just enough for what I need, and if I don't have another use case, I don't bother writing the code for it, because I'd get the test wrong anyway, and not know. Yeah.
So I have a question. So I would create like interfaces, like nested interfaces. Right? So the interface that and then some is like key types is like referring to other interfaces, right? So then later during the code completion, so you will only show the most optimal level of your whether it's type or
So this would be like if status also had another field, which I'm not having trouble naming at the moment, like that.
yes.
So you've got object literal types nested inside your interface, and then if I declare something as a caret, or no, it was a status, but a status has a caret, right? And I wanted to say status.caret. Come here. No, why do you not have any suggestions? Object is possibly undefined. Stop being optional. Status.caret. Dot flavor.
Yeah.
Okay, so go ahead.
So I guess so if you mouse over status, the capital status.
Capital status.
Yeah. So does this? Yeah. So okay. So I guess this one does show it, right? So it's so because like but then let's say if you define flavor as its own interface, and then you say caret is a flavor, right?
Oh, caret would be a flavor.
Right. So if you interface flavor, right, and flavor is or something that exactly, and then that getting status, then you say caret is a flavor type, right? And then later when you mouse over status, then I think it will only show that it's referring to the flavor, capital status.
Yes, caret is a flavor. Yeah.
So then you wouldn't be able to see the nested interfaces.
Right there.
Which literally still exists. So I just find it a little bit. So if you do have like nested interfaces in there, then it's easy. It's just really. I wish that there's a way that I can just show it just spread it out so I can see what are all the allowed data types to be in there.
I wish it would do that for type interfaces. Because if I go to like one of my real things and lint.ts, that's not interesting. And if I go to like one of these, then it goes down into the type declarations, and I'm like, okay, all right, but what is this? And it's like, well, it extends these, and I'm like, well, what's in those? And it's like these, and I'm like, what's this? And it's like, well, it's one of these or an array of one of these. And I'm like, what's that? And it's like, well, it's a function of these. There's a lot of clicking into stuff.
Java IDEs have clips that have often solved that problem, like a type explorer. It's usually a separate field or something. It's not even coverable, but if you really have lots of nested stuff, you can explore it.
Yeah, it wouldn't shock me if there were a VS Code plugin. There's a VS Code's got
Yeah,
plugin.
yeah.
And it doesn't exist in code. What do you think, Russ?
You can make it in 2 weekends and patches accepted.
It'll be half-assed. You release one, it'll be famous, and then move on. You reminded me of another question. What do you use for TypeScript documentation generation? I see you using js.tl.
Oh, we use TypeDoc.
Okay, just straight TypeDoc.
Yeah. Yeah, it makes some docs. It's okay.
I see you have much the same opinion.
It's okay. What is it? Taco doc? Taco like raining. Oh, compo doc. Oh, okay. I like taco doc better. Okay, when you make it, can you name it? No, that was the pain that we were going to make. Yeah, I would like taco doc.
So I like the method of showing how to adjust your configs as you're starting from scratch and moving through.
Or starting from JavaScript and
Yeah.
increasing, yeah.
If you were trying to put TypeScript into an existing project that you have, would you take the same approach of typing the noose, or would you take
Yeah.
a different?
I would do the noose tightening thing. The other thing you can do is you can leave a lot of the files as JavaScript. And there's a compiler option for whether the compiler should check those. And the linter has the same thing. Should it operate on the JavaScript ones or not? So then you can move it over file by file if you want. Also, I would very liberally use the ignore comments because those just sit there so that you can gradually get rid of them as you happen to be in the code and are already thinking about what this code is doing. Is a great time to remove those and add the types and let the types check your mental model for you of what you think it's doing. So I would probably wind up writing well, I'd write a code transform anatomist is what I would do. But effectively, a function to change all the files to be like, where's there an error? Ignore, 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 ignore. And don't feel bad about using those. Those are perfect markers of my head isn't here right now. I know there's a thing, but I want all my new code to conform to the stricter type checking.
It's the equivalent of a to-do.
Yeah, it is. It is. And then I would probably make a code inspection that whenever I make a push, it tells me how many of those I have so that it can tell me how many I've decreased by in that push, and that would just make me happy. That's
Also, some of them, it's not really a to-do, it's, I'll get, well, you can't really get rid of it later, because on a project I worked on previously, our TS-lint prohibited using null. It was pushing towards fine. But we're an Angular project, and there are some Angular APIs that use null. And so I had to use null, and TS-lint did not like what I was doing in order
right.
to use Angular correctly. So I had to put
Oh yeah.
one of those in there, and that's not a,
That one's not a to-do,
that's not
right?
one line.
Yeah, that's a real one.
That's good to know. I didn't realize that you could ignore it line by line. So whenever I tried to jump into TypeScript the first time, I did an existing project and it was just like throwing stuff.
Yeah.
Like, you can't.
Oh, the other thing you can do is just ignore them. I mean, you can just use the JavaScript, but that's a negative because then you don't see the errors that you just added that you do want to see, although you will see them in your IDE in the code you're looking at.
Yeah. I mean, like just like the mental churn of seeing all those. Sometimes too much. So.
Yeah. So I would stick those ignores. And good point. Sometimes those ignores are permanent, and on one or the other of those, I would probably put a comment as an exception.
We have a coworker who's splitting time between two projects at two different clients. One client is a bunch of Java developers who don't quite understand JavaScript stuff. So they set the TS-lint setting so that every single declaration needs to be typed, even when it's just food equals string, always. And on the other project that he's on, it's a JavaScript developer who isn't really fond of types at all. So there's implicit and explicit any's everywhere. So
Wow.
and TypeScript is flexible enough
Yeah.
for that, but it's almost like working in two different languages as he goes from project to project.
Yeah, that would be hard. Yeah, because we don't just work in languages, we work in language systems, and that includes our team. And it includes this community. So one of the advantages of the JavaScript ecosystem is people like you and me out there talking about it and deciding what's the best way to do this and which which documentation library sucks a little less. And which NPM libraries will make you feel better about how bad the rest of them are. Yeah, so thank you for that. Okay, I guess we should wrap up.
Cool. Yeah. So again, if there are no other questions, then thank you for coming out tonight. We will see you in 2 weeks at FullStack. And if you have any questions for us, please stop by or message us on Slack. And take food. So we don't have
Oh, and take some stickers.